Good morning. So next experiment we are going to see about the electro-pneumatic trainer kit. So this we call as here electro-pneumatic trainer kit. So with the help of this trainer code, we are going to actuate the double acting cylinder with the help of the solenoid valve 5x2 solenoid valve. To actuate that solenoid valve, we need this electro-pneumatic trainer kit. So in that electro-pneumatic trainer kit, we are having the switches, electrical push button operated switches, lever operator switches and relay coil operator switches. Okay, so with the help of these switches we are going to actuating, or we are going to giving signals to the solenoid. Through that we are going to actuating the double acting cylinder. So in the first switch we are having the electrical push button switches. So here normally open coil, if you energize this, it can be converted as here normally closed one. So by default it will be normally open. So if you actuate this push button, it can be connected into normally closed coil. So it's a electrical push button operated switch. So this is a fuse supply for this pneumatic board. If you give the connection as a fuse supply, so they will enable the electrical signal to all the switches. Okay, so now we see the electrical section 24 volt DC supply for the push button operator switches, lever operator switches, also relay coil switches. Okay, if I press a push button, so that normally open can be converted into normally closed. So by means of push button operator, I go for actuating or converting the switches to normally closed one. So like this in the case of lever operator, so it's electrical SPDT switch, nothing but single point double throw switch. So if I actuate this lever, so normally closed can be shifted to normally open. So I shifted the electrical supply from L2 to L1, that means normally closed to normally open. So with the help of the lever operator switch, I can switch the electrical power supply from normally closed connection to the normally open connection. Likewise in the case of relay module, here having the two relay modules, in that we are having the three relays. With the help of energizing the coil 1, so I giving the positive and negative power supply to this 2 port. So with the help of the coil energizing, I am going to switch out the power from normally closed to normally open coil. So in that common terminal we are commonly giving the electrical signal, so that commonly given electrical signal can be switched directly to the normally closed switch by default. If energizing this coil 1, that can be switched over from normally closed to normally open coil. So for that purpose we need the relay coil. So this can be energized with the help of the separately we are giving the positive and negative power supply. So this we call as here timer, electrical timer kit. So here we are having the three timers. We are mechanically adjust the timing values. So here we are having the port. So this 2 port indicates a positive and negative power supply for the timers. They are commonly interconnected. So at any one point we can able to give the positive and negative power supply. So for individual timer 1, timer 2 and timer 3, we are having the separate input and output. For this particular timer, we are able to give the timing value, that means input time electrical signal. So if we give the energize this, or we are giving power supply to this input, the timer start running. After that we are making some time seconds. After that we are able to produce an output. So from that output we are able to give the next actuation. So for that we need the timers. So we call it as a electrical timer. For in the case of single double acting cylinder or one double acting cylinder actuation, for A plus we are go for the manual actuation. For B plus, after time delay we go for actuating the B plus. For that we need the one timer. If we go for the two double acting cylinders, so A cylinder, cylinder B. So in that case we need the 3 timers. So A plus can be done manually by means of pressing the lever operator switch. Then B plus can be done with the help of the timer 1. Then B minus can be done with the help of the timer 2. And A minus can be done with the help of the timer 3. So each and individual timer we need the input, the timer will produce one output. For this timer we are going to give this as a input, they are able to get the output in this port. We are going to give timer 3 as a input, then for that they are able to produce one output, timer 3. So this timer can be used for making delay in that actuation. Like if you go for A plus and A minus, so A plus can be done by with the help of the manual operator switches, then A minus can be done with the help of this type of timer control. After the time limit, After the T on timer, they are able to produce one output. So that can be actuated by the A minus by the help of the solenoid operated DCV. So here I am going to actuate the single double acting cylinder actuation. So A plus, A minus. So with the help of 5/2 solenoid operated DCV. So the 5 port number indicates port number 1, 5, 3, 2, 4. Odd number indicates input, even number indicates output. So the two actuation or the spool movement, left and right actuation of the DCV can be done with the help of this positive negative, or in the case of electrical signal. So that will trigger the relay coil, so that will make the right actuation. If you go for giving the supply to this left actuation, they will make the spool movement inside the solenoid valve to the left actuation. Based upon that, we are able to get the output in the port 2 as well as port 4. So this is a FRL source. We have taken the FRL source from the FRL unit. So from that commonly connected port, we are going to give the connection to the FRL port. So this we call as a input. Okay. From that we are going to connect with the 2 port of the double acting cylinder. So in that experiment we are go for explaining the single double acting cylinder actuation A plus, A minus with the help of the Electro Pneumatic trainer kit. So now I give the circuit connection for single double acting cylinder actuation with the help of the 5/2 solenoid operated DCV. So I taken one power source from the FRL to the input 1. So the output from the 5/2 solenoid operated DCV can be connected to the double acting cylinder piston end as well as the rod end. So pneumatic circuit connection can be over. So now we go for move on to the electrical circuit connection. So with the help of the electro pneumatic trainer kit, so I am going to actuate the single double acting cylinder with the help of solenoid operated switch. For that I go for first actuating the So I give the electro pneumatic trainer kit connection. So I taken the power source from So when I go for given connection to the from the lever switch, normally open connection to the common terminal. So in relay model 1 I taken, in that relay 1 I taken, so I give the connection from normally open to the common terminal. So in that normally closed and normally open coil, I am going to give the positive power supply of the solenoid operated DCV. So that red color indicates a positive. So I am going to give the positive power supply of the solenoid operated DCV. So one in normally closed, other in normally open. So I taken common source from the normally open to the common terminal. Then in this two normally closed and normally open can be given to the 5/2 solenoid operated DCV. Okay. So next I go for energizing the coil. So from the common terminal, I am going to give the timer input. So this is a timer input. So I am going to give the timer. For this timer from the common terminal, I am going to give the timer input. So this timer will produce one output. So this output can be given to the relay coil 1. Okay. So timer output can be given to the relay coil 1. Next, this timer board, it needs one separate power supply. So this interconnector, blue color, it indicates a positive supply. This yellow color 3 connections indicates a negative. At any one port we are giving the positive and negative power supply from the DC source. So from the negative connection to the negative, then I taken one positive from the fuse to the positive power supply. So I given the power connection for the timer board. So positive negative power supply. So next I go for interconnecting the two negatives. So In solenoid, I have the two negative, so two black color, so that indicates a negative. So two negatives can be interconnected. Then I have the coil one negative and here one negative. So here also one negative. So all the things can be interconnected at a one place. That means grounded. So I taken two solenoid separately interconnection. Then I taken one coil negative interconnect with here. Then directly you are giving negative to the fuse. I taken another wire. Then interconnect here. Left it over here. Then give to the coil negative. So as of now, my circuit connections were over. So I give the connection. So one power supply for the board, positive and negative. So I taken the SPDT switch, reverse switch, one normally open to the common terminal. From that normally closed and normally open, I taken to the solenoid operated DC, 5x2 solenoid operated DC, both end. So the negative can be commonly grounded. So now I go for the simulating this experiment. So if I switch on that, so power can be transferred from normally closed to normally open to the common terminal to this solenoid. Okay, so this wire connection will give this solenoid this end. Next, after some time, the timer will get on, they will produce output. Now the power can be switched out to normally open. Now it can be transferred to the other end of the solenoid operator DC. Okay. So when I go for the simulation of WRT cylinder with the help of 5x2 solenoid operated DCB. If I operate the lever operator switch, okay, the power from the normal terminal, closed terminal can be switched over to normally open terminal. So from the common terminal to the parallel, I can enable the pneumatic cylinder. Okay, so once again go for simulation. If I switch that, I am able to get the extension of singularity cylinder. So from the common terminal to the normally closed to this actually relay coil of the solenoid to the cylinder extension. So after that, the timer will produce an output. So that will energize this coil. From the coil, the power in the common terminal can be converted to normally open. From the normally open to the solenoid rod to the solenoid retraction. Okay. So this is a power connection simulation of WRT cylinder using 5x2 solenoid operated DC. I go for once again the simulation. So extension. So after some time second delay. So here we are get the LED indication of output produced by the timer. That time we will get the WRT cylinder retraction. So this is simulation of WRT cylinder using 5x2 solenoid operator DCB with the help of electro pneumatic trainer kit.